Imagine Earth 4.5 billion years ago, a time when our planet was nothing like the blue and green oasis we know today. A hot, molten ball of rock and gas swirling in the vastness of space. The surface was a seething cauldron of molten lava, constantly churning and reshaping itself. Volcanoes erupted with ferocious intensity, spewing rivers of lava and clouds of poisonous gases into the atmosphere. The air was thick with the stench of sulfur and other noxious fumes. Meteors bombarded the surface relentlessly, each impact vaporizing anything in its path and adding to the chaos. These cosmic collisions were both destructive and transformative. This was no place for life as we know it. The landscape was desolate, a barren expanse of volcanic rock and ash. But over millions of years, Earth began to cool. The relentless heat started to dissipate, and the molten surface slowly solidified. The fiery surface solidified into a rocky crust, creating the first stable land masses. These early formations were the foundation upon which our planet would build its future. Water vapor in the atmosphere condensed, leading to torrential rains that lasted for centuries. These rains filled the basins and formed vast oceans. This was the beginning of a new era. The primordial seas were the cradle of life, teeming with the potential for biological evolution. This was the canvas upon which life would soon be painted. The vast water bodies provided the perfect environment for the first simple organisms to emerge. The early Earth was a harsh and unforgiving place. Extreme weather conditions and violent geological activity were the norm. Temperatures fluctuated wildly, and the atmosphere was toxic, filled with gases that would be deadly to most forms of life today. Yet within this chaotic environment, the seeds of life were sown. Simple, microscopic organisms began to thrive in the nutrient-rich waters. The stage was set for a drama billions of years in the making. From these humble beginnings, life would evolve and diversify, leading to the incredible complexity we see today. The early oceans were not the clear blue waters we know today. Instead, they were a chaotic and dynamic environment, filled with swirling currents and turbulent waves. The skies above were painted in hues of pink and orange, a stark contrast to the blue we are familiar with. This was a world in its infancy, a planet still finding its form and function. They were a murky broth, rich in chemicals and minerals. This thick, soupy mixture was teeming with the raw materials necessary for the birth of life. Particles floated freely, creating a dense, nutrient-rich environment that was ripe for chemical reactions. Scientists call this the primordial soup. In laboratories around the world, researchers attempt to recreate these ancient conditions, mixing various chemicals in hopes of understanding how life first emerged. This soup contained the basic ingredients for life: water, methane, ammonia, and hydrogen. These simple molecules, though unassuming, held the potential for incredible complexity. They were the building blocks from which all life would eventually spring. These simple molecules, bombarded by energy from the sun and lightning, began to interact. The energy from these natural forces acted as a catalyst, driving chemical reactions that would otherwise be impossible. Lightning storms and solar radiation provided the necessary spark to kickstart the process of life. They formed more complex molecules like amino acids, the building blocks of proteins. Amino acids are essential for the formation of proteins, which are crucial for the structure and function of all living cells. These complex molecules were the first step towards the development of life as we know it. Proteins are essential for life. They perform a vast array of functions within organisms, from catalyzing metabolic reactions to replicating DNA. Without proteins, life as we know it would not be possible. They form the structures of cells and carry out many important functions. Cells are the basic units of life, and proteins are integral to their structure and operation. From the simplest bacteria to the most complex multicellular organisms, proteins are at the heart of biological processes. The formation of these complex molecules within the primordial soup was a pivotal step. It marked the beginning of a journey from simple chemistry to the intricate biochemistry that underpins all living organisms. This transition was crucial for the development of life. It marked the transition from simple chemistry to the complex biochemistry that underpins all life. This shift allowed for the emergence of more sophisticated molecular structures and processes, setting the stage for the evolution of life on Earth. It was a slow and haphazard process, but over millions of years, the soup grew richer. The accumulation of various chemicals and the continuous input of energy led to an increasingly complex mixture capable of supporting the first forms of life. The ingredients for life were accumulating. Each new molecule added to the primordial soup brought the planet one step closer to the dawn of life. This gradual process laid the foundation for the incredible diversity of life that we see today. The next step in the journey was the formation of cells. Cells are the basic units of life. They are like tiny factories carrying out all the functions necessary for life. How did the first cells form? No one knows for sure. One idea is that fatty molecules in the primordial soup formed tiny bubbles. These bubbles enclosed collections of complex molecules, creating a stable environment for chemical reactions. These primitive cells, called prokaryotes, were very simple. They had no nucleus or other internal structures, but they were alive. They could take in nutrients, grow, and reproduce. The emergence of these first cells was a momentous event. It marked the beginning of life on Earth. These early prokaryotes were incredibly successful. They multiplied and diversified, colonizing the primordial oceans. Some evolved the ability to photosynthesize, using sunlight to produce energy. This was a significant development. It released oxygen into the atmosphere, a crucial step in the evolution of more complex life. Fossil evidence of these early life forms can be found in ancient rocks called stromatolites. These layered structures, built by colonies of photosynthetic bacteria, provide a glimpse into a time when life was just beginning to establish itself on Earth. Section 5, the Great Oxidation Event, a breath of fresh air. For 2 billion years, life on Earth consisted solely of single-celled organisms. Then something dramatic happened. The atmosphere underwent a dramatic transformation known as the Great Oxidation Event. Oxygen, produced by photosynthetic bacteria, began to accumulate in the atmosphere. This was toxic to many early life forms, and a mass extinction followed. However, this event also paved the way for the evolution of more complex life forms. Oxygen is essential for respiration, the process by which cells convert food into energy. With oxygen in the atmosphere, new forms of life could evolve, capable of using this vital gas to fuel their growth and development. Section 6, from one to many, the rise of multicellular life. About 1.5 billion years ago, a new chapter in the story of life began. Single-celled organisms began to cooperate, forming colonies. Over time, these colonies evolved into multicellular organisms. This was a major evolutionary leap. Multicellular organisms could grow larger and more complex than their single-celled ancestors. They could specialize their cells to perform different functions. This led to the development of tissues, organs, and eventually complex organisms like plants and animals. The first multicellular organisms were simple, soft-bodied creatures, but they were the ancestors of all the diverse and complex life forms that would follow. Section 7. Explosion of life, the Cambrian era. About 540 million years ago, life on Earth exploded in diversity. This period, known as the Cambrian explosion, saw the emergence of most of the major animal groups we know today. Creatures with hard shells, skeletons, and sophisticated sensory organs evolved. The oceans teemed with bizarre and wonderful creatures. Trilobites, with their segmented bodies and compound eyes, scuttled across the seafloor. Early fish with primitive backbones darted through the water. The Cambrian explosion was a time of incredible experimentation and innovation in the history of life. It was a period of rapid evolution that shaped the course of life on Earth. Section 8, from sea to land. Life conquers a new frontier. For billions of years, life had flourished in the oceans, but about 400 million years ago, life began to colonize a new and challenging environment, land. Plants were among the first pioneers, evolving roots to anchor themselves in the soil and vascular systems to transport water and nutrients. Insects, descendants of aquatic arthropods, followed, adapting to breathe air and developing wings for flight. The colonization of land was a pivotal moment in the history of life. It opened up vast new habitats and led to the evolution of the incredible diversity of terrestrial life we see today. Section 9. A new era begins, the dawn of the dinosaurs. In the vast expanse of Earth's history, few epochs are as captivating as the age of the dinosaurs. This era, marked by the rise of these magnificent creatures, began over 230 million years ago during the Triassic period. The stage was now set for the emergence of the dinosaurs. The world was a lush, verdant place, teeming with life. Early dinosaurs roamed these primeval forests, their presence hinting at the incredible diversity that was yet to come. From humble beginnings as small, lizard-like creatures, dinosaurs evolved into a staggering array of shapes and sizes. Over millions of years, they adapted to a multitude of environments, from dense forests to arid deserts, showcasing their remarkable ability to thrive in diverse conditions. Some were gigantic, long-necked herbivores that grazed on towering ferns. These gentle giants, like the Brachiosaurus, could reach heights that allowed them to feed on vegetation far out of reach for other creatures. Others were fearsome predators, armed with sharp teeth and claws. The Tyrannosaurus rex and Velociraptor, with their formidable hunting skills, dominated the food chain, striking fear into the hearts of their prey. Dinosaurs ruled the Earth for over 180 million years, a testament to their evolutionary success. Their dominance during the Mesozoic era is a remarkable chapter in the story of life on our planet. Their reign ended with a cataclysmic event, but their legacy lives on in the birds, their direct descendants, that fill our skies today. The asteroid impact that caused their extinction was a pivotal moment, reshaping the course of evolution. The story of life on Earth is a tale of constant change, adaptation, and survival. From the rise and fall of the dinosaurs to the emergence of mammals and eventually humans, each chapter is a testament to the resilience of life. It is a story that continues to unfold today, reminding us of the incredible power and resilience of life itself. As we look to the future, we are reminded of the lessons from the past and the enduring legacy of the dinosaurs that once roamed our world.